So, hello everyone. Thank you for joining us for this last conference, for the conference cycle of the Digital Twins Executive Master Program. So today we have the pleasure to have Stefan Mordio from Bentley Systems. So Stefan is a senior program manager for education and partnerships, and he's been working a lot on BIM for several projects and standard committees, and he also co-authored several books on BIM and received numerous awards for his work in the construction industry. So thank you again, Stefan, for being with us today, and we we are impatient to hear you talk about how you use digital twins with Bentley. Thank you.
Brilliant. Well, thank you very much for the kind invitation and a warm welcome wherever you're dialing into today. Thank you very much for joining us, and hopefully you'll find this engaging and worthwhile, and hopefully you can take a few kind of snippets away. So just before I start, who am I? I've had a bit of a brief introduction, but my name is Stefan Mordio. I'm a chartered architect by profession, so I spent a number of years in professional practice. I've also got a master's degree in construction project management, and I've had a really varied career within construction. I would say a really rewarding one. I've got to work with standards committees. I've got to work with practices, engineering companies, not just here in the UK, but right across the globe. I've worked a lot in consultancy as well for the likes of AECOM and Cohesive. But my current role is I'm the senior program manager for education partnerships at Bentley, and really my passion and my heart really lies with education and academia. I've got lots of interests, particularly around digital construction. I wrote a book, BIM for Construction, Health and Safety, which actually this year marks its 10th anniversary, which is absolutely astonishing. There's my little nephew there. He wasn't very pleased that he got that as a birthday present, but never mind. And I thought, just because we're talking to a French institution, BIM for Dummies has also been translated into French as well, which I thought was fantastic. Okay, so Bentley Education. I'm sure you've heard of Bentley. Hopefully you've heard of Bentley Education, or I'm here to tell you a little bit more about what we do. So essentially, Bentley Education, we're here to empower students, educators, academic institutes. So we provide access or free access to our extensive suite of software for academic purposes. But actually, it's a lot more than that. We run competitions, we've got tutorials, webinars, lots of things going on. So have a look at the portal as well and get familiar with that. So today we are obviously here to talk about digital twins. Now, I'm sure many of you are familiar and aware that infrastructure is really complex. We've got this interconnected system of systems. And I think it's unique because our infrastructure is really long-lived. It spans decades or even hundreds of years. And it's really critical to solving our current challenges that we have. So around climate resilience, energy security, and all of that stuff. But I think we all realize that the sector is also experiencing lots of huge issues. So we've got this growing demand. We've got increased demands on our resources, so water and energy. We've got aging infrastructure. We've got assets that are in place that need to meet the sustainable goals and things like that. We've got data fragmentation. So we produce lots of data, perhaps more data than we've ever had before, but it's still siloed and it's really complex. And so we've got lots of resource constraints as well. We've got an aging workforce. And so we've got all this going on. So this puts lots of pressures and issues, but it also gives us an opportunity. And it gives an opportunity for all of us to reimagine how data, how our processes, and how our technologies can work all together to solve some of these big issues of the day. So with infrastructure projects being so complex, we need better ways to manage them. And I think, through infrastructure digital twins is the way that certainly Bentley are reimagining how projects and how assets are designed, how assets are built, and how they're operated. And I think digital twins offer us this kind of unique way to manage the life cycle of complex assets, particularly in urban environments, campuses, cities, so I think this is kind of really the way forward. So this kind of got me thinking, often when we think of technology and how it evolves, it doesn't really evolve. In fact, I think that it kind of jumps. And sometimes technology can really jump in unexpected ways. So just think about the humble camera. So at some point, somebody thought, we can combine the camera with the smartphone. And that has just really untapped a completely new world for us. And then along came the drone. And then somebody had a fantastic idea. Let's put a camera on the bottom of the drone. And so these have really jumped in unexpected ways. And that's given us so many new opportunities, particularly when we're thinking about LiDAR and point clouds. And we can capture information very quickly, very rapidly. So this is Lord's cricket ground. So think about photogrammetry as well. So capturing 3D data in really extraordinary detail here. So as an architect, when I was practicing, the idea of going out and measuring something was really complex, particularly when we're talking about existing infrastructure, when we're talking about complex historical buildings as well. So being able to capture this information really quickly and accurately I think is really astonishing. But we've got all this data. It's in all different forms. It's in different locations. So how can all this information then come together? So this is where Bentley comes in. We've got our iTwin technology. So the ability to combine that photogrammetry detail in reality meshes. We can combine it with CAD models, with BIM models. We can add streams of time data from sensors. But really importantly, we can deliver that through a standard web browser. And we can show that at city level. And I'm going to show you a little bit about some of that in a moment. And that to me is really kind of transforming. So let's sort of talk about what a digital twin is. You're studying, of course, on digital twinning, so I don't want to go in too much detail about what it is, but again, from a common point of view, it's about connecting different data systems together. It's about streamlining processes and workflows. It's about improving collaboration and transparency. So we can start to visualize and track changes. We can use immersive visualization. And so this is really just the start. So it's really an exciting proposition. So in iTwin, the I stands for infrastructure. So it's infrastructure digital twin. And that's kind of how we describe it here at Bentley. So an iTwin is composed of all that information, all the associated data that represents an infrastructure asset. So that data can consist of design files, reality capture, schedule data, sensors, and so much more. So here's one of our founders, Keith Bentley, and I thought this is really nice, simple quote. And he says, regardless of the infrastructure type, over time, the digital twin of an asset or a project will become both its lifeblood and a central nervous system. So it's going to be real key to everything we do. But Keith also had this vision as well. So we believe that to achieve sustainable infrastructure digital twins, it's really important that we build our systems around open source technology. So that's really going to be the key. So that's something that Bentley have been involved, not just in acknowledging, but also as a real mindset, so helping the industry develop it. So Bentley have been a founding member of the Digital Twin Consortium, also multinational members of Building Smart International, so supporting IFC for digital twins. So regardless of whatever kind of vendor or technology solution you're using, there's a kind of a number of steps that typically we go through. So first of all, we want to create data or make use of our existing data sets. And so we've got a range of solutions for that. We've got iTwin Capture. Next, we want to start to consolidate that data. So we want to pull it all together. And this is where we've got a resource called Open Cities Planner. And again, I'm going to show you some really cool examples of that. Then we want to be able to enrich that data. And then finally, we want to start to analyze it and present it and visualize it as well. So again, we've got tools for virtual reality and simulation and some really nice things like that. So here's an example. Here you can see how this is MicroStation. So it's managing a model. Here we're in Helsinki city centre. So it's really comprehensive. We've got lots of reality meshes going on that have been divided into rectangles using a grid. And then there's attached property sets to that as well. So just looking at the detail here, you can see for a city, it's very, very high. We can see the rivers, we can see the bridge, we can see the trees, and iTwin's managing these really big models with no performance issues whatsoever. So here's another example. We're looking at Siemens real estate, again, using iTwin technologies. And this is a digital blueprint of a campus, and it's using a mix of inventory data, proposed projects, and real-time IoT data. And that's going to be the foundation of this really ambitious vision for this Siemensstadt Square. So here you can see clicking onto a particular asset, I can start to see associated property and gain real insights into that. Again, you can see there's not really many performance issues as well. So looking at existing utilities and things like that. So then we want to think about how can we enrich the model. So we can use our enterprise connectors and we can start to form live links with lots of different sources of maybe corporate information or GIS data as well. So this is Sydney Airport, obviously over in Australia, where they've adopted Bentley iTwin to provide what they describe as a self-service cloud-based portal. So anybody can go in and they can get quick access to lots of data that's going to support decision making around facilities. Maybe you want to look at a particular plan or 3D, look at something in 3D of areas for maybe planning, maybe it's auditing or maintenance. And so this integration is providing real-time collaboration coupled with 3D viewing capabilities as well. So you can see it's all very intuitive, particularly the way we navigate around the models. So, using the mouse, certain gestures on the mouse as we get familiar with gaming as well. So a lot of the navigation features will be you'll see it's very, very similar to that as well. So then we want to start to kind of visualize that data. So data can be very complex. So visualizing it in a very simple way makes it really easy to understand. And we're starting to host lots of tools that are bridging that gap and going into the world of gaming, really. So looking at Unreal engines, Unity, and so forth. Then we can start to think about using sensors and operational data. And this really creates a better consumer experience. So with iTwin IoT, you can start to gain performance insights, particularly around critical infrastructure. So we can look at health, condition monitoring. So here I'm just showing you an example of a twin. We've got data from lots of different agencies, so all open source information, and we're federating it into a single environment. So we can see information both at a macro level and also at a micro level as well. And we can share this with multiple stakeholders. So it's a really great way to get everybody involved in the process. So, you know, we can cut through the building, we can click, it's very interactive. So you can see that information coming from some of the sensors. And this is being explored on a much larger scale. So this is the city of Singapore. And this model just absolutely blows my mind. So we're looking at very complex data that's covering water, it's covering energy and transport and so much more. So this is a nationwide scale digital twin. And I think this is really groundbreaking, and it's really going to make big improvements to water, energy, transportation, and planning as well. So you can see how the gaming engine can be used for a really fully immersive experience. So we tend to think of maybe a digital twin as of a particular asset, but actually digital twins can be multiple assets, multiple sites, campuses, or in this example, you know, showing an example of a city scale digital twin. And then finally, we move into simulation. So we've got tools for simulating and starting to show data in real time. So we can show things such as charging data. We can start to map maybe air quality, vehicles, bikes, pedestrians. And here, just showing you it in reality. I find this model really mesmerizing. So here you're looking at the simulation of traffic. So red, obviously the slower traffic, going through to green, which is the faster traffic. So very quickly we can start to see hotspots, and we can start to make decisions based on this simulation of the data. So where might we need to put an intervention or traffic intervention? Where do we need to free up vehicle movement as well? So again, just another example there to show you. So just in summary, we've got tools that are providing capture, consolidating, enhancing, enriching the model, analyzing it right through to visualizing it. And the most important thing is we can share it through a simple web browser. Okay, so I wanted to try and make this session practical and give you just a couple of top tips and some things that I think you should be thinking about when you are starting to maybe develop your own digital twin. Now, the first thing, this is going to sound crazy for me being from a technology vendor. The first thing is we're not thinking about technology. Your first consideration shouldn't be technology. The first question I think you should be asking is, why are you doing this? So what is the value proposition of your digital twin? What is the strategic use case? So is your strategic use case around energy reduction? Is it around maybe providing an autism-friendly campus? I'm going to show you an example of that in a moment. So you may have multiple use cases, but making sure they align back to your organization's value statement so everybody's clear about what it is you're doing. What is the purpose of the digital twin? So start with the end in mind. So next, I want you to start thinking about the maturity of the digital twin. So again, digital twin may be a bit of a buzzword, and we need to really break it down to what do we actually mean? Are we talking about a static model? Are we talking about something that's got a one-directional flow of information? Or actually, are we talking about something that's a bit more sophisticated and has got a bi-directional flow? So we can update information here and it update the model and vice versa. Or are we really talking at the other end where the digital twin starts to become predictive and controlling and is giving you kind of thoughtful insights? So there's a whole spectrum. And again, it's about selecting something that's appropriate and proportionate to what it is you want to achieve. The third thing I wanted to bring to your attention is about this scalability. So I've just showed you some examples of a nationwide, citywide digital twin. Is it something at a campus level? Is it a building? Or do you need information right down at a component level? And this is going to be varying depending on, again, what it is you're trying to achieve. So if you're doing a very long linear railway line, that's going to look very different to a building or a university campus. And the fourth thing is, think about your starting point. So now you know why you're doing this. You can start to think about what data, what information do we need to support that? But also think about what data you already have. So maybe you've got some CAD drawings, maybe you've got some models, maybe you've got a BIM, maybe you've got some simple geometry, maybe you're starting from scratch. Maybe you need to get a drone up and do some LiDAR. Maybe it's about digitizing some existing information. Now, we can get off the ground very, very quickly. I mean, the latest iPhones have LiDAR technology, so you can capture information very, very quickly. So just thinking about your use case then. So this is Dublin City University, one of our universities that we're partnering and working with, and they've got a fantastic digital twin. Now, their objective was to investigate the use of a digital twin for contextualizing the campus and helping the public and the staff and the students and visitors to orientate themselves around the campus with a particular emphasis on autism. So students could get an understanding of where the quiet spaces are, of a particular route where they need to go to. And you can see this has been brought into a gaming engine. So it's very easy to kind of navigate around and interact with the model. Here we're interacting with particular different sensors. So again, just thinking about your use case. When I think about a digital twin, I try to think about different industries. So what are other industries doing? What can we learn from them? And often the parallel, or right at the forefront of digital twins, we think about Formula One. And I love watching the Formula One, and I love seeing these pit walls at the side of the track where they've got the team principal looking at all these different screens, getting instant real-time feedback, not only about the car, but also about the driver. And they're gaining insights all the time. So it may be about the heat of the engine. It may be about the vibration of the engine. It may be about oil temperature. Now, in isolation, those data sets aren't really telling them anything. But when they pull those data sets together, it actually starts to predict, the engine may fail, or we need to do an intervention. The thing is, this assumes a good base level of information. So it assumes that we know about the car, we know about the engine, we know about the components. And in F1, they probably do. I would argue that when we look at construction and infrastructure projects, often we don't have that understanding baseline information as well. So that's something we really need to think about. Now, to build up good insights from a digital twin, we need to build up good information, structured information as well. So again, just something to think about. Now, you may be familiar with, these are the Gemini principles. They've been around for some while. They were released back in 2018 by the Centre for Digital Built Britain. But I still think they're still relevant, and it's a really good framework to start thinking about the development of a digital twin. So there's 3 groupings and there's 9 areas. So we've got purpose, trust, and function. So when we're looking at purpose, think about public good. So how will your digital twin maybe benefit society or your organization? How can it benefit the environment or maybe the economy? Does your digital twin improve the quality of life for students, for staff, for example, if you're looking at a digital twin of your campus? And then we start to look at value creation. So how does it create tangible value? For example, is the focus on reducing energy consumption, or is it on improving infrastructure resilience? So think about the value. And then insight as well. So think about measurable goals that reflect the insights that you aim to gain from your digital twin as well. So this might be around predictive maintenance, it might be about optimizing traffic flow in urban areas, whatever that may be. And then think about trust as well. So security, we need to think about implementing strong cybersecurity measures. So particularly when we're sharing sensitive data, we need to be really mindful of that as well. So who are we sharing it with and for what purpose? Openness, this is really, really important. And again, this is a strong emphasis for us here at Bentley. So embrace open standards, embrace interoperability. So make sure your digital twin can integrate with other systems and that you can share data effectively. Now, I would love for you to use a suite of Bentley products, but equally you may be using different pieces of kit from other vendors, and that's probably how the real world is going to be. So it's really important that your system that you choose is open and can play fair with all these other systems as well. Quality, so think about the quality of your data. So make sure you're regularly validating it and updating it as well. So you want to make sure it's reliable and that you can trust it. So finally, we move down to our functional set of principles. So federation. So your twin should be part of a larger federated ecosystem, if you like. And then we've got creation. So it must have clear ownership and governance. So who's going to be in charge of updating it and controlling it? So that's really important. And then evolution as well. So develop your twin so it can adapt with the future. So technology is going to adapt, file formats are going to change. There's going to be lots of technology which is going to be here in 5 years, which isn't here now. So make sure you've got that flexibility. Okay, so it was just a couple of principles I wanted to share with you then. So as we step into the future of what I call a smart city, university campuses for us, or certainly for Bentley Education, is a real perfect way to experiment and implement a digital twin. So they're vibrant, diverse environments. We've got lots of elements that are very similar to a city. We've got lots of buildings, we've got car parks, we've got open spaces, and it makes it an ideal way to test and refine digital twin applications at manageable scale. So we're working with a number of universities to really push the forefront of digital twin. And I was fortunate to go over to Lithuania a few weeks ago with some colleagues and meet the team at KTU, and they're using Bentley technology, amongst other technology, to create a digital twin. So some of the key principles that we developed that on was, first of all, developing it with co-creation. So lots of stakeholders, get various people involved and get their buy-in. The other thing was about focusing on a demonstrator project. So exploring the boundaries. So what can we really use this digital twin for? Let's play around, let's experiment. And by working with universities is great because, very clever people, very forward thinking and very willing to try out things. So that's great. Also, again, making sure the data is open and accessible so everybody can use it and everybody can benefit from it. And then the fourth thing we looked at was looking at different scales. So looking at a digital twin, which would look at the whole university campus, but down at a building level, a space level, and also down to an equipment level. So we're proud to be one of the partners for this. And I'm going to show you a bit of a live demonstration now. So what could possibly go wrong? So this is a live real-time digital twin. So there may be a slight lag, as you appreciate, we're going over the internet, but this is all just purely through a web browser. So anybody can kind of access it. And here is the extent of the campus. So you can see it's pretty extensive. So literally just using the mouse, I can zoom, I can move, just very, very simple to navigate, using kind of gaming technology. One of the top tips I would say is, make sure you've got somebody who's going to be really leading your digital twin project. So one of the researchers at the university was really interested in drones. He went away, he got his drone pilot's license and got the drone up in the air. And again, it wasn't an expensive piece of kit. It wasn't a professional piece of kit or anything like that. But very quickly, they were able to get a large reality capture area of the whole university campus. And very quickly, you can see it's got the foundations of the twin starting to come together. So in this particular twin, we've got photogrammetry, we've got a few BIM models, we've got internal 3D views, we've got some sensors going on, we've got a bit of analytics and machine learning, and some other technologies have been used on it as well. So monitoring is provided by collecting data from different APIs that are being broadcast in real time by more than 2,000 parameters from physically installed sensors around the building. So here I can click on the main lab building like so. And I can, for example, look at the occupancy. Now, why would I want to capture occupancy? Well, it's great because it starts to give me insight. I can see maybe from a catering point of view, what days are most busy for students on the campus. So have I got enough food in? From an energy consumption point of view as well, we can see is there certain days of the week I can turn lights off and all things like that. So there's lots of insights that we can gain from looking at things such as occupancy. And again, this is in real time. So we've got one person on the second floor at the moment. I think it's probably lunch. So everybody's probably out in the sunshine at the moment. We can also look at an indoor view. Now this is just going to take a moment to load up. So like I say, I am doing this live. It is retrieving information. So it may just take a few seconds to pull through. So just while that's loading up, we have got some time for some questions as well, so we can explore that in a little bit more detail. So I'll be struggling a little bit because I'm sharing my screen and my camera, but I will just pull through in a couple more minutes. There we go. So here you can see I've got a model of this particular building. Again, it's about being appropriate and proportionate with the amount of detail that you need. So in this particular model, we didn't need anything, highly graphical. It's almost like just looking at bounding boxes. So I can go look at, I'm on the basement, and this is where we can now look at some internal views. So I'm down in the heart of the building. So here I can see I've got a sensor on this particular piece of kit. I'm not sure what the kit is, but here I can look. So I'm talking to this particular sensor, and hopefully, yep. So this is giving me some temperature readouts, and I can start to look at trends. I can look at relative humidity. I can also look at indoor temperature as well. So I can start to gain lots of insights. And we've got lots of different temperatures and sensors on fridges and all sorts throughout the building, which is really cool. And again, some of these 3D views, you can, set up sophisticated image captures. But again, from your phone, there are apps where you can take a very, very quick internal scan. And that might be proportionate and relevant to what you're doing. So this is really good for wayfinding as well, for having a look around the building. Okay, so I can also look at some utilities. Turn these on. So here I'm looking at underground utilities. So this is really good if a third party is maybe coming to do some work to try and locate where some of these critical infrastructure is. And again, just being able to open a web link and share that web link, and anybody can go and kind of look at that, I think is fantastic. We've also got a number of EV charging points on site which have sensors on. So again, real time, I'm looking at a particular charging station here. I can see the last time it was connected. I can also get some insight around carbon footprint as well. There's another one here. So this one's ready. So last time it was used for 3 hours and 55 minutes. So just showing you kind of the art of what's possible by just some simple sensors on there as well. So the real strategic use case for KTU, sorry, I've had too much coffee, was around energy consumption and trying to lower that. And the only way by doing that is to really understand what's going on. So we can look at all sorts of dashboards here. We can look at, this is a federated view of CO2 footprint, and you can see it's presented really nicely in these graphs. Again, very simple. So we can see where the footprint's coming from: electricity, from waste, solar power, EV charge, and thermal energy as well. We can look at that by hourly if we wanted to. We can look at it by daily. We can also look at waste as well. So we've got certain sensors. We can look at where that waste is coming from. So glass, paper, plastic, etc. And yeah. Okay, so there is KTU. You can see, again, just a simple web browser. And you can see how this could connect to another campus. And it's, yeah, I think it's fantastic. So that kind of takes me to the end of today's session. I wanted to leave 15 minutes or so for questions and answers. So I'm going to hand back over to Jeremy, and maybe we can get some Q&As.
Yes, thank you very much, Stefan. Thank you for the very nice presentation, very live. So yeah, if you have any questions, you can either unmute yourself or type in the question in the chat. Yes, Juan, please.
Hello, Stefan. I would like to ask about simulation, because I think that which Bentley is different from other companies as Autodesk, for example, is that it has a lot of software that can perform calculations like, I don't know, plaxis or structural calculations and traffic, hydraulics. And is in this moment integrated all your products in this platform? So, for example, can I perform simulations in Plaxis that can be integrated into a digital twin with your iTwin platform, for example? Or you need to do some external modification to pass, for example, the calculation from this software to a database that is the one that this platform use, or I don't know if you understand what.
Yeah, I think I do. I'll be honest with you, Juan. It's probably a bit more technical than kind of my knowledge. So drop me an email at stefan.mordew@bentley.com, and we can have a conversation, look at that process and workflow, if that would help.
Yeah. Okay.
More than happy to discuss that in a bit more detail.
Yeah. Okay. And your email is in.
It's so Stefan.Mordew. I'll just share that. So I'll put it into the chat for you.
Perfect.
And if that's an area simulate, of particular interest, we can always come back and do another session on that if that would help.
Thank you, Stefan.
You're welcome.
Okay, we have another question. Kelsey, please.
Hi, Stefan. This was fascinating. I was wondering if, actually more of your industry opinion, what do you think is the biggest challenge to organizations adopting the iTwin, and how do you anticipate Bentley addressing those blockers in the future?
Well, that's a great question. I think a lot of the challenges aren't really, they're very rarely technical challenges. So they're very rarely around the actual implementation of the technology itself or the software itself. Installing it's pretty easy, purchasing it, procuring it or whatever is really simple. And I always think that the technology will always resolve itself. The bit that I guess is often the blocker is kind of that mindset change as well. And really thinking about the value of what it is that you're going to use. So I was saying earlier about when you're building your digital twin, before you've even thought about your technology stack and what you're going to use, think about what it is you're trying to do, what it is you're trying to achieve. That will then inform what data you need to get and also the technology that you've got. Now, that technology may involve Bentley software, it may involve some other pieces of software, it may involve a ecosystem of different things that all play together. So if you are making a decision on procuring some technology, make sure it's open, make sure it's agnostic as well, that it's future proofed as well. So you want to get good value from your investment. So I don't know if I've answered your question, but that's kind of my top tips, I would say.
You did very well, thank you.
So maybe related to that, you spoke about Bentley having this interest in using open source technology. So how does it work? Do you develop some microservices that are open source, or and then you build on top of that you have the development of a tailored product to sell?
Yeah, so we have lots of APIs that are open, so other developers can develop on our platform, can integrate with our platform as well. But the Open City Planner technology, which I showed you, can ingest, I think it's something like 30 or 40 different file formats. So that may be microstation, it may be a Bentley file format, it may be Sketcher, it may be something else, it may be a variety of things, because we realize that information is coming from all different areas. So being able to ingest and use different file formats is really, really key. And that's a mindset that Bentley have really tried to adopt. So, being part of the Digital Twin Consortium, being part of Building Smart, being part of the development of IFC and things like that, again, is really, really important to us.
So do you think that since we don't have any proper standards yet for digital twins, so is it an obstacle or not necessarily, since you try to accommodate lots of different sources of data,
Yeah,
etc.?
Do you mean actually having a digital twin kind of standard or file format?
Yeah,
do you mean?
yeah, something like that.
I don't really know. I think we've got information's coming from so many different places. So as long as it can be integrated and used, that's really what you want to be aiming for. In an ideal world, we'd all have one file format, but that's kind of not the reality. So having something that can play with other other file formats is key.
Okay. Do we have another question?
I think having something in a browser as well, you know, because that negates the need to have software on your laptop, on your computer. You know, I've just put a web address in, and you know, I've got access to all that information. So that bypasses a lot of barriers, and I think makes it sounds a very simple thing, but actually it unlocks so much capability just by having it web-based.
Yeah. So how does it work if you have a client that wants a digital twin for his own assets that you develop for them? Then there's like obviously there's a development cost, and then do you provide the maintenance of the digital twin for some cost over some years, or then it's handed over to the client that has the charge of updating with data or new features?
So this is an interesting conundrum, and I think this has been around regardless of digital twins, regardless of BIM or whatever. So who's going to maintain and update your digital asset, whether that's a BIM model, whether that's a digital twin. So you've invested all this money in creating an accurate replica that's up to date. Now you're going to lose all that value if you haven't got some sort of strategy about keeping it up to date. And so it's a really, really important consideration. So it's a contractual thing. So who's going to be in charge of doing that? And just to give you a very simple analogy, I was working for a large government organization, and they had a lovely, it wasn't a digital twin, but they had a 3D model, and they put a lot of time into it. Now, somebody went to do some maintenance to the building a year, 2 years later. They went into one of the rooms expecting it to be 2 rooms, and then all of a sudden it's 1 room because somebody's gone in and taken the partition out but hasn't updated the model. So there is a degree of maintenance, and you do have to have a strategy around that about who's going to be responsible for that as well, but also what information you're going to update. So everything might not need to be updated. It might be a product sheet rather than the physical geometry, if you know what I mean. So yeah, there's a whole strategy and thought piece that needs to be considered about update and maintenance of your investment.
Yeah, I think that's one of the main obstacles also for some cities or people that to take to invest on a digital twin is also to
it is, but I think that dilemma has been around regardless of digital twin. So even when we were doing a CAD, CAD-based information, that you've got a built asset, you've got an as-built record information, then you go and update that asset after, who then updates the plan. So so this conundrum's always been around. It's not I wouldn't say it's a digital twin issue. It is part of a wider issue that's been around for some time.
And also maybe a question, because we are developing a master program for professionals to help them developing and digitalizing construction sector, etc. So in your opinion, what's the current needs in terms of training or skills for the new engineers in construction sector, etc., regarding this digitalization, let's say?
Again, it's a very difficult question, because you are essentially preparing students to solve problems that we don't yet know are problems using technology that's yet been invented. So, but it's around capability, it's around mindset. Now, obviously, I didn't really touch on it today, but AI is going to be a real game changer, particularly around digital twins, where you can start to make sense of the data and create new value and come up with ideas that you never come up with. So that's kind of the AI feeding it. So having an understanding of AI and how to use prompts properly in order to get results back, and being able to use it as your ally, really, as a tool. I think that's going to be a real interesting skill set. I don't think AI is going to replace us, but certainly using it as a tool to help us with mundane and repetitive tasks is, I think, where it can really help. So having a skill set around that.
Okay, so more like engineers with a positive attitude towards new technology rather than only data scientists.
Absolutely. So technology will evolve and adapt with or without you, regardless. It's going to change. So you either accept and embrace it, or it's going to happen anyway. So it's about looking at it with a positive mindset. One of the problems, I think, is when you start to look at the future and future technologies, we tend to think of, science fiction films and dystopian landscapes, and often it's a world which is very negative. I'm thinking like Blade Runner and RoboCop and things like that, and it's a horrible world. Whereas thinking about technology that's going to actually enhance our lives and make the quality of our life better, it's thinking of it in that particular mindset. And when we talk about AI and things like that, when you look at industry reports, yes, there are certain sectors and certain jobs which are going to disappear, but AI, I think, will generate more jobs as a result. So there'll just be new jobs in different areas that we yet haven't thought about. So 10 years ago, we didn't have an app developer. Now it's a really in-demand job, in-demand skill.
Okay, thank you. So do we have maybe one last question? No? Okay, otherwise I think we can thank you again, Stefan, for a very nice talk and discussion. And we'll upload the meeting on our YouTube channel quite soon.
Thank you. And just on behalf of myself and Bentley Education, thank you for having us today. And personally, I wish you all the best in your course and your careers. And please connect on LinkedIn, because I really like to see everybody flourish in their careers, and I love it when I see somebody really succeed. So please do reach out, and I wish you all the best.
Okay, thank you very much. Thank you again, Stefan,
Thank you.
for your
Take
time.
care.
Thank you all for attending. And this was actually the last session of this year conference cycle, and we hope to start again next year. Thank you again. Bye.